So today is your presentation for the lab. It's basically the what we call the replacement of your lab report. Instead of writing lab report, this time you need to present what you have learned during my lab lah. My lab is about organic chemistry. So we have two group now. We have Arina and also Khatijah, and also another group Fatih Humaira and Akil Ikmal. So these two group will present their work. For at least like 20 minutes like that per group, and then after the presentation, the attendee, the audience will ask the one question to the group, and then the group also will ask one question to the audience. So without further ado, I will ask the first group, Arina and Khadijah, to what we call to give their presentation. Okay, Arina.
Okay, Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon to everyone. My name is Aina Sofia binti Kamar Azlan, and this is my group mate, Khadijah Galib. So today we'll be presenting on experiment number 1 and 2, which is, as you can see, separation, purification, and identification of organic compound. So I'll be basically there are 6 main points in this experiment, whereby first we have liquid extraction. We also have precipitation, distillation, melting point, thin layer chromatography, and recrystallization. So my first part is basically the liquid extraction. As you can see, the objective of doing this procedure is to separate the mixture of organic compound from an aqueous solution. So here we have the first foremost. You just have to basically add 0.5 gram from each organic compound, which we have here is acid, base, and neutral, into a flask which we label as a shake flask. And then we add 10 milliliter of DCM, which is an organic solvent, into our shake flask. And together with that, after that, we'll put into a separating funnel. Aduh, jauh tak separating funnel tu. Okay. Oh, nak. Okay, next, we're going to start first with acid extraction, whereby first you have, just now inside of this separating funnel, we have the 3 compound, right? 0.5 together with 10 milliliter of DCM. So we want to extract the acid now. What we do, we put 10 milliliter of 5% NaOH, which is an aqueous base, into our mixture right here. And right after you put the 10 milliliter of NaOH inside, you have to shake and vent. This is to like let the chemical compound inside this here react with each other. Moreover, because we want to extract acid, right? So we let the acid to react with the aqueous base inside the solution. And then the procedure here is that you have to shake and vent the pressure inside. So you shake vigorously and you vent. You just do it for like 3 times, okay? Until you see like the 2 layers form inside of this separating funnel. So when those layers form, you have to, you note that the layers is basically at the bottom layer and the upper layer. The bottom layer, you have your base, neutral, and DCM, while your upper layer, you have your acid in aqueous base form. So you have the, it's like natrium salt of acid, which is the aqueous base. Okay, and then we do this, we repeat the extraction process for like, we do repeat for 2 times only, but you can do it for 3 times or as many as you want. And then the same procedure, you just add 5% of NaOH with the same volume as well. And then after several times, you will have 2 different flasks right here, which is the acid flask and the mixture flask. Okay. So moving on, just now we have the mixture flask, which contain of base, neutral, and DCM. We're going to do base extraction now. So how do we do that? We have to, just now we add aqueous base, now we add aqueous acid into the mixture of separating funnel. So we put 10 milliliter of 5% HCl inside here. And then we do the same procedure again. We shake it and basically just vent it for several times, and until a layers form again. So you know that the DCM is always like denser than water, so the aqueous will sit at top and the lower will also always have DCM. But this time they only left with natural and DCM because all the base is already going up here. Okay, and what it's up here is basically an aqueous HCl or a HCl salt of base. And yeah, you repeat the same process again and again. So until you get neutral extraction, where you're going to do the next procedure here. I think I don't need this. Hold on. Sekejap. Okay. High off. Okay. So basically just now you say like for acid, boleh patah balik tak? For acid here, we're going to go through acidification. Next. For base, we'll keep it for the distillation later. And for neutral extraction, we're just going to continue while you add 10 ml of water now into our neutral mixture right here. But you have to put inside different separating funnel. And then you basically just shake and vent it for just like before to extract the aqueous and the neutral to a different flask also this time. But the aqueous up here, we're not going to use it, so you can just discard it. Okay, so this neutral is what we're going to leave for DCM evaporation, because this one still have DCM, right? So we want the DCM to be evaporate, so that later we want to do the sublimation. Because sublimation, you don't need to have any like liquid inside the flask. So yeah, we just leave it for a week to let the DCM evaporate. And then next. So moving on to the second part, which is the precipitation. As you can see, the objective here is to precipitate a form of acid or base to let it coming out from the aqueous solution. And basically, this precipitation, like before you start, in order to get your precipitate, you have to acidify or basify the organic compound. Means that you have to sort of, if it's acid, you have to add more concentrated acid, which I'm going to explain later. So this is, the first one is precipitation of acid. So I put it as a make it more acidic, because here, as you can see, I've add 15 ml of 6 molar HCl, which is highly concentrated than the acid that we used just now, which is the aqueous acid only, right? So once you put 50 ml of 6 molar HCl inside, you are going to lift it inside the ice bath. Okay, so inside this ice bath here, you have to be aware that while preparing this ice bath, you have to insert some water. I mean like a lot of water, because you want to increase the surface area from this flask with the water around here, so that more concentrated area, so that one be precipitate more fast. And then once you done with this, you can see the photos right there. We want to collect the precipitate. Precipitate is like the mendakan, a solid thing. And then we use vacuum filtration. So that's how we use it. Basically, we have, okay, I'm going to see right here. So here is the starting procedure of vacuum filtration. We have the filtration funnel, the vacuum, as well as the Bunchner funnel. And we just put our solution just now from the ice bath. Once you already see like the precipitates coming out from your aqueous solution, you're going to start this procedure directly. Oh my God, okay. And then you just pour the, first you have to put water into this place here, and then after that, you're going to put your acid flask inside the Bunchner funnel and let it do the vacuum filtration. And right after that, you already got your precipitate out of this filtered paper. You're going to let it dry for the next procedure, which is the recrystallization. Okay, next. Okay, next step is precipitation of base, where I name it as a basification because we want to basify the base right now. So we add 15 ml of 10% NaOH, which is more concentrated than the one which used before, and that we want to increase the pH value even more for this one. Okay, so after we put the component right here, you pour it into the different separating funnel, and then you wash the base flask just now with DCM. You do it twice, 5 ml plus 5 ml of DCM, and then wash it and then put inside the separating funnel just now, right here. Okay, and then you do the same procedure as the extraction, whereby you shake it and vent the pressure inside, and then you'll see 2 layers form, just like just now. But this time, you collect DCM from the bottom, and the extraction will be repeating the procedure again, okay, with 10 ml of DCM. And then after do it for like several times. Oh, before that, once you add 50 milliliter of 10% NaOH inside our base plus right here, you'll see that kind of like cloudy whitish thing form. Okay, that is what we got as a basifying the base. That is what we got. And then the extraction is basically like the more that you do, the more uncloudy, the thing is not be as cloudy as at first times you saw that. Okay, so and then the DCM, basically you're going to collect it. Inside the DCM, you have organic base in the DCM solution, and that is what we're going to go through to distillation. Okay, that's it. Okay, now the last part for my part is distillation, where you want to separate this only for base, by the way, to separate the DCM from base compartment, base compound, by vaporizing it via distillation method. So this is distillation of base, where you have to add, inside, just now you have your base plus together with DCM and H2O, right? Now we want to start distillation. We don't want the H2O to be inside here. So what we do, we put anhydrous sodium sulfate, which is a drying agent, into our base plus right here. And you're going to see like, there's like a clump of white thing sit under your base plus. Okay, and then I'll just put like 1 scoop of that. You filter the components inside here to a round bottom flask, because this is what you're going to use for the distillation. This is what going to be sit on the heating mantle, the round bottom flask. So once you have already put that things in, now you have your base plus DCM. And what you do now, before you start the distillation, you have to put another boiling agent we call as anti-bumping granule. And the reason why we do so, because we want that anti-bumping granule is like it's porous, so it promotes boiling, and it's also preventing from the solution here to be superheated. 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 We call it as a boiling tube. Okay, and then right after that we just put and set up our apparatus inside this distillations arrangement here. Here you have the round bottom flask and the condenser, and this is the beaker which going to collect your DCM, because basically your DCM going to vaporize at 40 degrees Celsius. You have to keep away on this thermometer until it reaches 40 degrees Celsius, and it's going to condense the DCM. And here is what left with your base. Okay, yeah. Mana?
Assalamualaikum warahmatullahi wabarakatuh. My name is Khadijah binti Galib. My PIN number 20207880. Okay, so now I will continue presenting about the recrystallization part. So the objective of this part is to observe the recrystallization of organic substance, which is certain organic substance that will form crystal after a certain process. Next. So this is recrystallization of acid. First thing is we add half of dry acid. This dry acid precipitate is what we get from the previous experiment. So this dry acid precipitate we will divide into two. Half we put into the single solvent flask and half we put into the mixed solvent flask. Also in the single solvent flask we put 5 milliliter hexane, and in mixed solvent flask we put 5 milliliter hexane plus methanol. So then we heat up until boil, and then we cool down a little bit, and then we observe what happened. So for the single solvent flask, we can see that single solvent flask which is contain 5 milliliter hexane, we can see that there is a crystal form here. But for mixed solvent flask, there is nothing occur. There is no crystal form, because actually the solvent that we are supposed to do is to we need to put hexane, 5 milliliter hexane plus 5 milliliter methanol plus water. So that's why we didn't get the crystal form result for mixed solvent flask. Next. So next, sublimation, recrystallization of neutral compound. Okay, first we need to fill the test tube with ice. So, and then we make sure to label the flask. So neutral flask, we put the test tube with ice into the neutral flask. We clamp using a retorts tank, and then we put on the hot plate, and then we heat gently the bottom of the flask. We heat gently, and before that, yeah, after we fill the test tube with ice, we can see the water condense, right? So we need to always wipe the condense. So because what's that? Because after we if we put if we want to do next process and next stage, the condensation that appear may wash the crystal form away, the white crystal that occur after the heating, after we heat the flask. So that's why we need to always wipe the condense. Okay. And then we need to continue until all the compound has sublime. So basically the sublimation is the opposite process of evaporation. So kalau evaporation is from solid to gas, but for sublimation is from gas to solid. Next part is melting point. The objective for this melting point is to we need to identify the melting point of organic solid. So melting point here is when when we see the organic solid first melts until all the organic solids becomes liquid, which is completely melted. So first thing first is we need to crush the acid. We take a small amount of acid and then we crush it on the filter paper. So after that we take the melting point tube and then we do that to make sure the acid, the crush acid go down. So after that, we repeat the process for base and also for acid plus base. And then after that, we put onto the melting point apparatus. So this is acid. You guys can see. This is acid, base, and this is for acid plus base. So after that, we put all the melting point tube onto the melting apparatus. And then first we set the melting point apparatus to 55 degrees Celsius relative temperature, and then after that it will start heating. Once the relative temperature has reached, it will give a beep sound. So after the beep sound, you press start, and then it will start ramping. So after that, it will heating, and in the heating stage, you need to always observe carefully. Observe when the organic solid start to melt first, and when when it has completely melted. Next. So this is the result that we get. Initial temperature basically is when the solid first melt. So for acid, we got at 88.5 degrees Celsius, and final temperature, which is it has completely melted, 122 degrees Celsius. So for base, 59.5 degrees Celsius for initial, and final temperature 73.6 degrees Celsius. After that, the mix compound, acid plus base, we got 55.4 degrees Celsius and final temperature 66.5 degrees Celsius. So here we can see that when we combine acid plus base, our temperature, the melting point is more lower. It is because it is not pure. It is impurity substance. So it will start to melt more faster. Okay, the last part is thin layer chromatography. This in the objective. Okay, so the objective, one of the objective in why we need to know thin layer chromatography is because we need to determine the RF values. RF values is retention factor retention. So we next. RF values actually important because we can see whether the solute that we put refers to the solvent more or TLC plate more. So first thing, we prepare a test tube with 5 milliliter DCM, dichloromethane, and then we put a small amount of acid, base and neutral, and then we spot a droplet of each of these compound on TLC plate. Okay, on the other hand, we prepare also 2 flasks hexane plus ethanol, 10 milliliter of hexane plus ethanol, and for flask B, 10 milliliter of DCM plus hexane. But we put only 5 milliliter into the developing chamber because the developing chamber is quite small. Yeah. And then after we put the solvent, we need to close the lid to avoid the dichloromethane to evaporate. So after that, after we finish this with the TLC plate, we do the line lah. We label with in the TLC on the TLC plate 1 cm. Start from the bottom. Boleh like this. 1 cm from this and this, like this. Okay. After that, spot a TLC plate with a droplet. We put into the development chamber. So we after that we close the lid, and then we observe which one is which droplet will go, which solvent will go more faster to the solvent front, the line at the above line. Okay. And then after we get the result, the result is the first one, the first chamber, which is hexane plus ethanol, is more faster than DCM plus hexane. So after that, after we got the TLC plate, we got the result, we dry a while, and then we put it into we put it into we use shortwave UV light source on a TLC plate. After that, we outline the spot. So now this is the developer chamber and shortwave UV light, and this is the spot that we need to outline. Next. So here RF is the distance traveled by component. Distance traveled by component here divide by the distance traveled by the solvent front. Okay. So for the for the first chamber, which is ethanol plus hexane, we got the RF value for acid is 0.09 centimeter. while for base is 0.16 centimeters. And next, the next chamber, which is DCM plus HCN. For acid, the RF values is 0.20 and for base is 0.73 centimeters. So here we can see that the RF values for acid is more lower than the base. Okay, and yeah, apa ni? So basically acid, the distance from the pencil line here, for the both picture, we can see that it is shorter than base. So acid is basically refers more refers the affinity is more to TLC plate acid. For base, it is the affinity is more to the solvent. Next.
Okay, so now I'm going to start off the discussion. So the first discussion we have here is the precaution step that we have to take throughout this experiment, and as well as the consequences if you are not doing so. So the first precaution that I only take 3. There's a lot actually. You can write from the laboratory manual, but for the precaution, first precaution, you have to label all of your apparatus before basically starting your experiment. If not, you're just going to mix up all the organic compound, or you're using anhydrous sodium sulfate just now. You don't want to mix it with other granules or stuff, so you have to label it out, as well as your flask. And you don't want to mistakenly put your base into your acid flask, and because you're going to unattainable desired separation result. You're not going to get the result that you want. So the next precaution is that you have to wear your glove throughout the experiment to avoid direct contact or from your skin from any chemical compound, because you know that your DCM, for example, it's an organic solvent which is very toxic. It can penetrate to your skin and sometimes can cause like skin rashes and something like that, skin rashes, and yeah, you cannot touch it with your bare hands. And the last one is to use protective shield to prevent the UV light, which is the shortwave UV light, from your eye and your skin. So that's why direct exposed to UV light can actually cause skin cancer, sunburn, and cataracts in your eye. Kita tak pergi distillation dulu, dia habiskan.
Distillation.
Distillation, turun. Pergi dulu Boleh? Okay. So I'll skip to discussion number 3. This is for my part. I'm going to talk to you about the difference between the distillation that we are using and the fractional distillation, which we know that the industrial use, which is like, that one, that picture right there. That is the industrial use that you use to distill petroleum or crude oil by that fractional distillation. So you want to see the difference. Okay, first, for simple distillation that we use, basically we want to separate liquid with boiling point gaps at least 25 to 50 degrees. Actually, it's like around 25. It's like not that small, but it's medium. While for fractional distillation, you want to separate liquid with closer boiling point. And next, the simple distillation. Since the name itself is simple, so you have simple apparatus. You just basically need 2 flasks, the round bottom flask and the beaker at the end, and you need a condenser in the middle, something like that. And then, but for fractional distillation, it is more complex. You have like one fractional distillation with stages, like I'm going to show you guys later that. But then next, for simple distillation, there's like no repetition in the process, just going like one way. But for fractional distillation, you can repeat the method to gain pure components. And this is one example for simple distillation that we use, or the base distillation that we just do inside our experiment. But for fractional distillation, we use crude oil refining. So, what I'm trying to say right here about the fractional distillation. So basically, you're going to insert your crude oil inside here. It's going to heat up, going to bakar, and then once it heat up, the first like temperature range that you going to achieve is like lower, right? It's like 25 degrees Celsius to 30 degrees Celsius to 100 degrees Celsius and above. So once it reaches 25 degrees Celsius, it's basically there's going to like the gas coming up, whereby if it's, I'm going to put like a formula which I'll try to. Silap. These are like major things which I usually going memorize. Is basically if the things that you want to collect is lighter, it has low boiling point. For example, like your gas that you're using at home to cook, your petrol for your car, basically they are lighter and has lower boiling point, so they're going to extract from the top of from here. They're going to take from the top. Okay, they collect it from the top. While for heavy components, they have a higher boiling point, which means like they have, if you can see here, it's actually stated from this one is 25 degrees Celsius. Things that lower than 25 degrees Celsius is going to collect up here, while things like, for example, right here, it is 200 something, 230 to 300 degrees Celsius. So it's really high, right? High temperature. So it means it needs they are high boiling point. So you're going to collect it from the bottom side from this fractional distillation. So this is what they call as fractional distillation. I think. Okay. Oh yeah. So it's like in more appropriate ways that you want to what's this identify this thing, this fractional distillation, is that the crude oil here, they are heating them to a temperature at which one or more fraction of the mixture will vaporize, just like how I explained just now. But that is the appropriate ways to say it. You just heat them up and then collect it based on the stages of fraction. Okay, so that's it. Dah.
Discussion 1. Discussion 2. Okay. So discussion 2 is how extraction carried out in the industry. And for this part, I choose extraction of essential oil in industrial scale by solvent extraction. So there are many type of extraction actually, such as stream distillation, liquidic extraction, solvent extraction, and many more. And here I choose solvent extraction. So this is solvent extraction is one of the method that is mainly used in industry. So first thing first is a solvent extraction is basically we use to extract the aromatic delicate compounds such as which is the plant, such as jasmine or rose or something like that. That's aromatic. So in here the plant we will soak into the solvent. The solvent here is usually commonly used is alcohol such as methanol or hexanol. Okay. And after that, after the plant fully soaked into the solvent, it will evaporate. Here, and then it will go to the vacuum distillation, and here to get the alcohol, here, and then it will heat up in the above the vacuum distillation. So after that we can get the after the heating up, we will get the evaporated plant oil here. So this is absolute. Absolute is basically used for perfume or any cosmetic purpose here. like that. So last part of discussion is whether there are other type of chromatography technique. There are a lot of chromatography technique, but today I will talk about paper chromatography. So paper chromatography is the simplest and also the most widely used of the chromatography technique, and it also has various many type, which is ascending chromatography, descending chromatography, ascending, descending, radial or circular chromatography, and two-dimensional chromatography. But here I choose to explain more about the ascending chromatography. Next. So basically, ascending chromatography is quite similar with the thin layer chromatography that we have that we did. The difference is for TLC we use TLC plate, which is a silica gel in the plate kan, aluminium plate. And for paper chromatography, the paper that we use is cellulose water fiber. And also for paper chromatography, it will not trace under the UV light, under the shortwave UV light. And also because of that, the time range for paper chromatography is more longer than thin layer chromatography, which is for thin layer chromatography, usually we get the result within a few minutes, but for paper chromatography, it lasts until maybe 2 to 3 hours, like that, more longer lah. But it is more cheaper because uh, less preparation. So I think that's all from us.
Thank you. So ada sana.
Okay, thank you for group 1. So now it's time for question and answer. So I will give to group 2 to give some question.
My question is, when we use the distillation setup that there, we have two products, which is the one will flow into the flux, and the one that left residue in the what round bottom flask. My question is, when in petroleum refinery, there is a fractional like
Fractional
the
distillation.
708 fractional, right? There is still residue, which the residue is tar to make a road. Does the residue same as like we have a bottom round bottom flask that
Black oil.
no, the condition is in solid. Is it the residue in petroleum refinery solid or gas?
Oh. Tak fokus.
Yeah, already. You should. Come on. Okay. I stated that when it's at the bottom, which means you have a higher boiling point. When you have higher boiling point, which means that thing is heavy. So the thing is, because it's heavy, it's at the bottom and it's become like more viscous than the one which sit at the top, because the top is like I said just it's vaporized, right? Like our gas that we use at home, it's vaporized, so it's very light. But this one, since you ask the things at the bottom, right, they have higher boiling point and they are heavy, so the heaviness makes them that higher in viscosity. So they are sort of like, yeah, it's like liquid, but it's very viscous. Okay. That's my answer. Next.
Now we give the question to from the what we call from the presenter to the floor lah.
Bagi apa? Sekejap.
Bagi apa? Senang je lah. Question lagi.
Another two question.
Okay. Can you guys name us or just give any other precaution step that
We
we
need to
do?
follow
Yeah, we have to follow throughout
during
this
the
experiment. And what happen if we don't?
Wow, what happen
The
if
consequences.
the consequences if we don't follow the rules? Left hand.
Okay. One of my precautions that I know is we need to do the experiment one by one and no need to rush. Yes, that's what I learned from previous experiment that we did. Okay, that's it.
Okay, that's all from us. Thank you very much.
Thank you.
Okay, thank you for group 1. So for now, I will pass this presentation to group number 2. Okay, so group number 2, you can come in front and Khadijah, you can pass to Fatin, and I will pass this mic to Akhil.
Assalamualaikum warahmatullahi wabarakatuh. To Sir Wan, Dr. Raha and my fellow friends. So, I Muhammad Akil Kemabil Hairul Azman and this is Fatin Humaira. We are gonna present about what we did on experiment 1 and experiment 2 in the past 2 weeks. Okay, next. This one. Okay, first of all, we need to prepare a mixture where there is 3 mixture. It is acid, base, neutral. This is should be 0.5 gram actually for acid, base and neutral. And we put them in one flask and we add 30 ml DCM. In the instruction, it should be 10 ml DCM. So we misput the DCM 30 ml. So it will affect our next experiment. Next. Okay. The first section is extraction and precipitation of the acid. First, we need a retort stand to support a separatory funnel. Then, we put the mixture that we had into separatory funnel and add 5% natrium hydroxide solution, 30 ml, and shake it vigorously. And we vent it about 2 or 3 times. And then when we let it sit for a while, and then we can see a 2 layer. And at the bottom layer is DCM. And we open the stopper, I think, and into the mixed flask. And at the top, we pour into the acid flask. Next. So we repeat the extraction to improve the extraction efficiency. So we pull back DCM into separatory funnel. We shake it back vigorously and add new 5% NaOH solution. And the same, the bottom layer is DCM and the top layer is the aqueous. We pour into acid flask, and then we acidify the NaOH extracts by adding 40 ml portion, which should be 15 ml, but we need to times 3 from the actual portion. We seal the flask to mix the contents, and in the acid flask, we cool the resulting mixture in an ice water bath. And then we collect the precipitation using the vacuum filtration. Next. Okay. This is the extraction process, and this is how to hold a separatory funnel when we shake the mixture. Then we need to open to vent the gas. And this is the ice water bath. Before we to collect the precipitation using vacuum filtration. Alright, next. Okay, the second one is extraction of base and neutral. We have a mixture flask where it is the DCM layer, and we extract the DCM layer with 5% HCl 30 milliliter. And then we repeat the extraction of DCM with another 30 ml HCl. Combine the HCl extracts in base flask. In this flask, it has hydrochloric sort of base. I don't have. The DCM, we pour it into the neutral flask, contains neutral compound, which the acid flask we don't use anymore. So now we have only 2 flasks, which is base and neutral. Wash the neutral compound by using DCM in the neutral flask, and then we add 10 ml water. We shake, and now we have 2 layers again. The bottom layer is still DCM, but now we run the layer into the neutral flask and left the neutral flask. We need to let it slightly open to make it evaporate the DCM. Okay. Next. Okay. Now we left with only base, which in the base flask. We need to basify the HCl using natrium hydroxide 10%, 45 milliliter. We rinse the base flask using DCM 2 times, 5 ml and 5 ml. Using the same method, using the separatory funnel, we shake to make it mix, and then allow the layers to separate. The DCM layer will be at the bottom, and at the top we have DCM. At the top we have aqueous, I think. Aqueous. Yes. Then we repeat the extraction, same, using DCM, and combine the previous DCM with a new one. DCM. Place the DCM extract in separatory funnel, then add 20 milliliter water. So here we will use this to distillation in a distillation process. Then we need to add what? We need to add anhydrous sodium sulfate first. Then put boiling stones, which is anti-bumping agent that is porous, into the bottom of flask. And then we heat on the steam bath, which is we have there. When the distillation is and we know that there is no more drop of liquid of the process, so we remove the bottom flask. The leftover is the base. So this is the setup of base distillation. This is the steam bath, the white one, and this is the recrystallization of base. You can see that it's like a spider web, I think, and this is the base one at the bottom. Okay, thanks.
Takutnya.
I will pass it to Fatih and Maira.
Takutnya. Nampak tak? Okay. Assalamualaikum. Jaga. Assalamualaikum. My name is Fatih Humaira binti Muhammad Fairuz, and I am Akil's lab partner. And today, I will cover for the second part of lab experiment. Okay, for first part of second experiment is a recrystallization of the acid. For first step, what we do is we use half of acid precipitate from the previous experiment and put it in flask lab. And before that, we have to label as a single solvent flask. Okay. Next step is we add another balance half of acid precipitate and put into another flask and label as mixed solvent flask. Next is we have to pour 5 ml hexane in single solvent flask and 5 ml of methanol and hexane and pour into mixed solvent flask. Then we heat both flasks until it boils. And then after that, we let both flasks cool at room temperature. And we observe and record the data in both flasks, which it can be seen that for single solvent flask, crystal will form, while for mixed solvent flask there is no reaction occur because supposedly for the solvent we have to use mix between methanol and water, but in this experiment we use hexane and methanol, so there is no reaction occur. And before that, this is our group's result, while this is other opposite group result. Our group did not get the final result, while other group get. So this is the which we supposedly get this kind of result, which there will be a crystal form here. Next is sublimation of the neutral compound. First step is put flask contain neutral solvent on a hot place. Make sure that the solvent is from the experiment part 1, and then second step is fill ice in a test tube, and don't forget to wipe the condensation on test tube outer surface. This is to avoid error occur during the experiment. Okay. Third step is set up everything just like in the picture, like this. Then heat the bottom of flask. And then we have to wait for a while until we can see the final result. The reaction takes time to occur, so we have to wait. And lastly, we can see there is a white solid crystal form surrounding the bottom of test tube. We can see that gas has been turned into solid. When gas or vapor hit cold surface, it will become a solid like this. And this is the example of the white crystal. Okay, next experiment is melting point determination. First step is put small amount of acid base and mixture of acid base on filter paper. Wait. There should be a picture, but we did not manage to get the picture, so yeah, I have to draw. Okay, this is filter paper. Okay, and then wait. We have to label first. This is acid, base, acid plus base, and then we take a small amount of acid, base, and acid and a mixture of acid base. Like, yeah, it should be like this. And while we are doing like this, we have to be careful because sometimes sometimes things can happen which uh, this uh, this this acid this powder can mix in unintentionally with this base, so which we have to do one by one, okay, to avoid that kind of things. All right, and okay, for information, base, you if you guys want to know, base is actually in a big uh, big particle. Yeah, so in order to put in capillary test tube is very small in diameter, so a big particle cannot enter. So before that, we have to crush the base particle and turn into a small particle or powder, and then we can put one by one into test tube. Okay, next. Yeah. Before that, before we want to put the powder of acid base and acid and mixture of acid base, we have to prepare the capillary tube, which yeah, we have to prepare the capillary tube. We need at least 3 pieces of capillary tube, and capillary tube is looking like this. Actually, it's more panjang apa?
Long.
It's more long actually. So we have to break it into half, and it will be like this. Yes, like this. And yeah, we have to break it like this, and make sure the capillary tube is high enough to be inserted in the tube of melting point apparatus. Okay. Third step is we fill all 3 capillary tubes with the sample that we had prepared earlier. And while we are filling in all 3 capillary tubes, we have at the same time we have to tap it down the capillary tube while filling in. And yeah, most importantly is we have to label each of the capillary tubes to avoid confusion in the future. Right? Yeah. Okay. This is what melting point apparatus looks like. That before this, I mentioned that we have to break the capillary tube high enough so that the capillary tube won't stuck in the melting point apparatus. Because if the capillary tube stuck in the melting point apparatus, it will be hard to
get it out. Get it out. Pull it out.
to bring out. Yeah. So, and after we prepare the capillary tube with the sample, we put the three capillary tubes in the tube of melting point apparatus like this, and make sure you remember what is what. Like example, this one is acid, base, and this one is mix of acid and base. And then turn on melting point apparatus and set the plateau at 55 degrees Celsius. And then okay, and then after it reach the plateau 55 degrees Celsius, it will let out beep sound, and then when it reach that temperature, then we can start ramping temperature. And yeah, and then after that we observe carefully and record the result of the melting point of the compound when it start to melt, and the melting point of the compound when it is completely turned into liquid. And lastly, after all the sample are melt, we can stop heating and yeah, and this is the result. Yeah, if you guys see, there is a range in our result at acid. This is because we missed
To record.
the time when the melting point of the acid compound when it start to melt, and also we also missed the melting point of the compound when it is completely turned into liquid. Yeah, this is the range of where acid going to be melt when it start to be melt, and this is the range of when acid is completely turned into liquid. And yeah, this is our result for base and also mixture of acid and base. Next. Thin layer chromatography. Okay, next experiment is thin layer chromatography. First is we take 3 test tube and put acid base and also neutral in 3 different test tubes, and make sure to label all 3 test tubes so we won't confuse in the future. And then after we put all the sample, acid base and neutral, then we have to dissolve them in 5 ml DCM. And yeah, and then next step is prepare lagi. Next step is we are preparing the developing solvent, and first flask is mixing of hexane and ethanol with measurement of 9 to 1, and another flask is mixing of DCM and hexane with measurement 9 and 1 2. So total we will get 10 ml for both flasks. First flask of hexane and ethanol we get 10 ml, while another flask of DCM and hexane we get also 10 ml. Third step is pour 4.5 ml of each developing solvent in developing chamber, and make sure after we pour the solvent, we have to close the lid immediately to avoid the solvent from evaporate to the air. Okay, and then label both chamber accordingly. Then we take 2 TLC plate and mark horizontal line from 1 cm from the bottom and 1 cm from the top. Like this means yeah, and then yeah, and after we mark horizontal line 1 cm from the bottom and 1 cm from the top, label the TSC plate, and also do some and also mark 3 spots for acid, base and neutral, like this. Yeah, and then we have to prepare 3 capillary test tube, 3 open end capillary test tube, and start spotting at the place that you had labeled earlier. Means the capillary test tube we use before this we have prepared 3 solvent, right? So with that 3 solvent, we have to use 3 open end capillary test tube, use this capillary test tube, and
and dip into the 3 solvent that we had prepared earlier, and then spot on the mark that we had do early year. Okay. Next. And then after that, we take the plates out of the developing chamber and let it dry for a while. During this part, we have to be careful because some of the solvent are fast to absorb, like the mixture of hexane and ethanol absorb the fastest. So while we are doing that, we have to we have to observe carefully so that we won't miss the
Outline.
it, like so that it won't melebihi
Acid.
exceed the level that we had marked earlier on. And then after that, we use shortwave ultraviolet light source to detect the components, and it is like this, and then draw the components outline with pencil. During this, we have to be careful because we are handled with shortwave ultraviolet light, so it's quite dangerous. So we have to be careful while doing this. Okay, next. Then we measure the distance traveled by each components. This is hexane and this is DCM and hexane. This is the result. In order to measure this, how do we get A? A is the distance from. Can you guys see the picture? Okay. This is how you guys get the A, distance for A. And this is acid and this is base. Wait. So, to get DCM and hex for acid, we have to for distance A, we have to take from the bottom here until the middle of the acid compound. So here, this is the distance for B. Then we calculate like this, and then this is what we get. Okay, next is DCM and hex base. We do the same thing. Take the bottom and then until it reach the middle of the base compound, and then we calculate and then we get this result. Okay, next. Yeah, we do the same thing to ethanol and hexane for acid and ethanol and hexane for base. Yeah, like this. And then we record the data and determine the identity of the unknown. For this experiment, we don't have to determine the identity because we already know the identity, that's why we can skip the part of determine the identity of the unknown.
Okay. I will continue discussion session. The first one is safety and precautions. Firstly, we need to always wear gloves because in the laboratory, we don't know what substance or element that we touch. Sometimes it can be harmful, hazardous, or corrosive. Then, this is what I said just now, previous. Okay. We need to do an experiment one by one because when we rush to do something, we will left the previous experiment. Then we need to we will forget to record something data. Then make sure eyes are on the same levels as meniscus to avoid parallax error. This is important when you want to take a sample in using a test tube. We need to make sure our eye same level as the meniscus level. So the So the measurement is precise. Yes, that is what I want to say. The third one. Next. One more.
Okay.
Okay. Distillation process. So the first one is the experiment distillation, known as simple distillation. In this experiment, the boiling point for the solution I think is 40 Celsius, and it only has two products that will flow into the flask at the end, and the one that left over in the round bottom flask. A simple distillation process, because there is no conversion and treatment process such as petroleum refinement. Next, petroleum distillation. It's transform crude oil into useful products such as naphthalene, LPG, like gas we use in home, kerosene for airplane, and the residue is the leftover is tar to make road, and has various boiling point because what is Rin said is fractional, because the lower when lower boiling point, it is light, medium, and heavy. Heavy which has high boiling point. So in this petroleum distillation, it uses heat, pressure, catalyst, and sometimes hydrogen to crack heavy hydrocarbon molecules into lighter ones. Okay. So,
Discussion for question 2 is about extraction process. Example of extraction. Kejap. Wait. Ya Allah. Tak apa. Okay, extraction of process is liquid extraction. So, example on how extraction process is carried out in the industry is by liquid extraction. The main process is it is a main process in the chemical and pharmaceutical industries to separate products from each other. Liquid extraction is based on different solubilities, means different distributions of a product in two coexisting liquid phases. For the equipment, they use there are two types of extraction equipment, which in batch mode process, we are using mixers and reactors. Next, in continuous mode process, we are using mixer, settlers, and column. This is because we want to transfer an organic compound that is dissolved in an aqueous phase to an organic solvent. For information, aqueous solution containing the solid is added to a separatory funnel, and organic compound partitions into the organic phase based on its higher solubility in the organic phase than the aqueous phase. Okay. Next is HLPC. Apa soalan nombor 4 ni? Soalan nombor 4. Sekejap. Sekejap. Okay. There is another type of chromatography technique which is HLPC. It stands for High Performance Liquid Chromatography. This technique is used to separate a mixture of compounds in an analytical chemistry and biochemistry, so as to identify and quantify or purify the individual components of the mixture. This HLPC is very highly improved form of column chromatography. The pressure makes the technique much faster compared to column chromatography, and HLPC also highly automated and extremely sensitive. Yeah, that's all from me. Dah. Any question?
Okay, okay. Thank you, group number 2. So now I will open the floor to the group number 1 to ask a question. So those who want to ask a question, come in front, eh?
Boleh tak slide previous slide, please? Okay. Kan no. Next. Okay. This that highly improved. It said that HLPC is highly improved form of column chromatography, right? So,
Okay.
what is that? Why it is more kita lagi guna prefer HLPC instead of color chromatography.
Alah, tak ada gambar.
Tak ada gambar. Differences dia je ke?
Wait. Highly. Yep. I mean, the form of column chromatography. HL.
Ke sebab pressure.
Sekejap.
Kan katakan highly improved form of color chromatography kan. So apa yang buat dia macam what makes the HLPC is the improved form of column chromatography?
In terms of the technology, HLPC are more advanced compared to column chromatography. And yeah, if we want to compare, when the technologies are more, advanced, so there will be new
technology. New type.
Bukan. New
information.
Bukan. Alah, wait. Diam. Dia apa ni? Dia kan bila teknologi tinggi tu kan mesti akan ada
Specification.
Spek baru kan. Spek baru tu maksudnya macam dia buat benda tu lagi jadi lagi lebih baik lah daripada the previous
teknik.
Bukan teknik, previous chromatography tu lah.
Yalah, teknik.
Teknik.
Okay.
Okay.
Thank you.
Let me add a little bit about this. First, this is not the one that the name is not actually HLPC tau. It's HPLC because high performance liquid chromatography. So basically the column chromatography is basically they use column. The one that you use using a thin layer, right? Thin layer of paper or whatever, and then they coat with the silica. The difference is that they just use a column like a cylinder like this, and then inside this they put silica. Okay, They don't put silica, they put whatever they think lah. Because for example, the silica, the one that you see in what we call, the one that you do in your lab is basically using silica. Silica, they separate things based on polarity. Something attached very strong to the silica, something is not attached very strong to the silica. But inside this, you can put anything. I mean, here also you can also put other thing than silica. For example, let's say a protein, maybe they can bind very well with a certain compound. Maybe let's say compound X, so they put compound X inside. So it doesn't need to be silica. Silica is just example. Okay. So the column chromatography, they can use pressure because, for example, this thing they send the pressure here, meaning that they can push the thing. It's not using this what we call, when you do in the lab, they have this what we call the capillary action, right? Up, down, right? But for the column chromatography, they push the thing using the what we call the pressure lah. So it's more what we call, you can replicate lah. You can replicate and so on. It's much more control than this, because this is depend on how the preparation and so on, and maybe some of the component, some of the chromatograph, I mean the compound itself cannot really stick very well on this. So this you can compact inside and so on lah. So now the question to the what we call, to the
Khadijah.
group number 2. Anyone? You want or you want to ask?
For Orin and Dija, so can you state that what is disadvantage from the petroleum distillation? What is the the disadvantages?
I think I would just like say it like logically, because petroleum distillation, you know that you use a very high temperature. So when you're dealing with a very high temperature, you have very high risk. Compared to this one, you're just using. I'm not saying that simple distillation doesn't have any risk. It still have risk, but we only do until the experiment that we do. We only do until 40 degrees Celsius. But for petroleum, we do up to 300 or maybe like 400 to 500. I'm not sure. Yeah, that hundreds of temperature. So maybe there's, if in terms of risk, if like let's say if an explosive going to be happen, the things that the explosiveness in petroleum distillation is much more higher risk than the one which we use the simpler distillation. So that's my answer. Thank you.
Okay, thank you for both what we call, for both group. So that's basically conclude our presentation, and thank you.